Okay, so this next problem, the problem with the 65,000 solar cells, each 1.25 inches by 2.75 inches, so little rectangular cells, that would be 1.25 inches by 2.75 inches. They're covering this prototype shown actually to the right. And your job is to figure out how much surface area in square feet must be covered with the cells. So you know that it takes 65,000 solar shells to cover the heliotype and the helioprototype, and you know the size of each little cell. And we're wanting to be in square feet, but our values are in square inches. And then there's the whole second part of the problem about efficiency, which for right now I'm going to hide. We're just going to focus on the first question. So I need to look at my final question. I want to know how much surface area in square feet. Oops. I want to look at how much surface area in square feet must be covered with the cells. So when I start this problem and think about how I want to arrange my dimensional analysis, I want to figure out over here, first of all, how many square inches I have. So I know that I have 1.25 times 2.75 square inches for one cell. But I also know that I have to think about how many square feet that is. And this is where a lot of people make a mistake. So if I look at a square foot, if this is 1 foot, and this is 1 foot, this is 12 inches, and this is 12 inches. So we know that that's 144 squared inches. And so basically we know that 1 square foot is 144 squared inches. And I'm going to use that whole little thing, that piece, all of that together. So I'm going to take this information here and say that from this information, I know that 1 square foot well, that my units right here that I'm left with are square feet per cell. And so, remembering my question, I want to figure out how much surface area in square feet that I need to cover the cells. So this up here tells me that I have 65,000 of these cells on the prototype. So my units that I'm left with now are square feet per prototype. Whoops, I don't know what happened there. So this is the only set of units that I have left. So that's gonna be my surface area. So I'm gonna pause this and calculate that out with a calculator. So when I calculate that out, looking at my calculator results, I get, with a little bit of rounding, 1,551.65 square feet per prototype. So I would say about 1,552 square feet. That's the surface area. And then the next thing is we want to go back and look at that question. I have to pause to stop it from hiding. Okay, so now that that's readable, we're looking at this efficiency. So the ones in this picture are 18% efficient. And the question is, what if they were only 12% efficient? Like, they say ones in homes are used, which, by the way, this is an old book, so I'm guessing these numbers are a little bit different. But let me just shrink some of our workup that we have already used. So we're going to be looking at this number right here. That's how many square feet that we would need if they were 18% efficient. But if they were only 12% efficient, that means we get 2/3 of the efficiency. And the question is, how much more surface area would we need to cover in order to deliver the same amount of power? So I'm going to have more surface area. So 2/3 of our bigger surface area. So we're going to have to figure out how much more of that surface area. So 2/3 of the new surface area has to work at the same energy level. So what would the new surface area have to be to do the same work as an 18% efficient set? So that's how I would set it up. I know that I'm going to need more cells because they're less efficient. So I'm going to say 2/3 of a certain number that I'm looking for is going to be equal to 1,552. So I'm going to multiply by 3 here. So this is no longer really a dimensional analysis problem. And then I'm going to divide by 2. And when I do that, I get, I don't know what I get. I'm going to just do that right now. So 1,552 times 3 is 4,656. Divide that by 2, and that's 2,328 square feet. So I'm going to take that value and subtract out my 1,552 square feet to see the difference. And I'm doing that, and I get that I'm going to have to cover an additional 776 square feet of surface area to deliver the same amount of power. So kind of summarizing, if we have 18% efficiency, we only would need to cover 1,552 square feet. But if it's 12% efficiency, less efficient, you have to cover more surface area. And to figure out how much more area, we know that it's less efficient, so we're gonna have to take 2/3 of a bigger number, more surface area, to achieve the same amount of energy. So I set up sort of a one-step equation. All right, we can talk more about this in class tomorrow, but that's just sort of a little bit of dimensional analysis and just a little bit of problem solving.